All right, we've been working with buoyancy, which is the upward pushing force that a fluid exerts on an object when you put an object in the fluid. And today I have 5 fluids. I have maple syrup, dish soap, salt water, regular tap water, and some canola oil. These are arranged in order of their density, with maple syrup being the most dense and canola oil being the least dense. Now what we're gonna do is we're gonna put an egg in each liquid. And gravity is going to pull down on the egg with a certain amount of force, but the liquids are all going to push up on the egg with different buoyant forces. So the first one I put in is an egg into maple syrup, then an egg into dish soap, then an egg into salt water. I lied about the densities. Then an egg into fresh water and an egg into corn syrup. Wait, canola oil. Okay, now what you're gonna see here is that the egg floats highest in the maple syrup. It sinks in the dish soap, which I found surprising because I thought that was gonna be denser than the salt water. It floats in the salt water, but notice that it's not floating as high. It sinks further down. Completely sinks in the water and it completely sinks in the canola oil. Now what's happening here is gravity's pulling down on all 5 of the eggs with about the same amount of force. But the different liquids are pushing up on the eggs with different amounts of force. We learned last week that buoyancy is an upward pushing force that a liquid exerts on an object submerged in the liquid. But what we didn't learn was the strength of that force and how to figure it out. When you put an object in a liquid, it displaces a certain amount of liquid. That means when I put the eggs in the glasses, it displaced some liquid and the level of the liquid went up in all of them. The upward buoyant force that a fluid exerts on an object is equal to the weight of the fluid displaced. I'm gonna say that again because it's important. The upward buoyant force that a fluid exerts on an object is equal to the weight of the fluid displaced. Have a look at this one. That's an egg in water. When I put the egg in, it displaced an amount of water that's exactly equal to the volume of the egg. Now, the weight of that much water is not as much as the weight of the egg itself. And that's why the egg sank. The downward force was bigger than the upward force. Same thing in the canola oil. It displaced an equal volume, same as the egg, but the weight of that much canola oil is not as much as the weight of gravity pulling down on the egg. Now, the salt water. Well, the egg tried to displace its same volume, but it didn't need to. As soon as it displaced enough salt water that the weight of that salt water was equal to the weight of the egg can float. Same thing with the maple syrup, but the egg's floating higher in the maple syrup, and that's because maple syrup is denser than salt water. You don't need to displace so much maple syrup to equal the weight of the egg. The weight of the egg is equal to the weight of the maple syrup that was displaced, and now the forces are in balance and the egg is floating. Forces are also in balance in the salt water, the egg is floating, but it takes more salt water to have the same weight as the weight of the egg. Now there's a slight imperfection in this experiment. I could have done it a little bit better in a more controlled way, and I'll ask that in the final question. Hope that helps you understand buoyancy a little bit better.